All right, so we're looking now at horizontal projectile motion. So with this, guys, we're not going to be given any speed in the vertical direction, in the up or down. So it's either something basically going to be just completely launched horizontally, or it could be something, dropped. But for the most part, everything will be launched horizontally. Now, when that happens, we have no forces in the x direction. No, we're neglecting all forms of air resistance, so nothing is going to wind up causing it to speed up or slow down in the x direction. In the y direction, we have gravity. We're going to use negative 10 meters per second squared for this. So right here, they're saying a baseball is dropped off of a cliff, and it accelerates to the ground at a rate of 10 meters per second squared down. Meanwhile, a cannonball is launched horizontally from a cannon with a horizontal speed of 20 meters per second. Fill in the position timetable at the right. Okay, well, we have to do a couple of different things. So first, we have to figure out, all right, y here, all right, our heights of the baseball. So for the baseball, your y would basically be our dy. So it's going to be 1/2 gt squared is what we're going to do. So you're going to square the time, and then what's 1/2 of negative 10? Negative 5. So you're going to square whatever the t is and multiply it by negative 5. So for this dude, all right, obviously anything 0 is 0. All right, 1 squared is 1 times negative 5. What is that going to be? Negative 5. Okay, 2 squared, 4. 4 times negative 5, negative 20. So can I zoom in? There we go. So I'm using right now, all right, this equation, vertical displacement. So basically how much it's going to drop, or what rate it's going to drop distance-wise, based off of just because gravity is causing it to accelerate. So if you just think about something, right? If you start it and let go of the ball instantly out of your hands, it's 0. 1 second later, gravity is speeding it up. Now, you cool with the fact that the longer something's in air, the faster it's going to continue to fall? All right. Yeah, I'll show that in a sec. All right. So the next second, it's going to speed up, so it's going to fall a little bit further. Third second, it's going to be speeding up and fall even further. So for the math for the baseball, you're doing 1/2 gt squared. All right. If g is negative 10, 1/2 of negative 10 would be basically negative 5, and whatever t squared is. So 1 squared is 1 times negative 5 is negative 5. For the second, 2 squared is 4 times negative 5, negative 20. And then 9 squared, or 3 squared is 9. 9 times negative 5, negative 45. Okay, 4 squared times negative 5 would be negative 80. And then the next one, 5 squared is 25 times negative 5 is negative 125 meters. So this would be negative 80, negative 125. And then you were like, oh, they're going to tell you to try and just trace these in. This is 5, 10, 15, or something along those lines. There should be 4 little tick marks in between. That's 10. This is 5. So the ball would be there. Then at negative 20, negative 45, negative 80, and then negative 125, if we were to draw those paths in. So in order, if you know how long an object has been in air for, All right, and we're just worrying about what distance it's fallen. You're going to use that equation. dy is equal to 1 half gt squared. We're using our negative 10 for g. So 1 half of g, if g is negative 10, that's why we have negative 5 here. And then you're just squaring the times and multiplying out. Now the negative, guys, is indicating displacement. All right, your vertical displacement. So remember, you can have a negative displacement. That's just telling you now, okay, the ball landed at the very bottom of this 125 meters below. But if the question asked, how high did the kid drop the ball from? What would your answer be for that? If the displacement is negative 125, remember, can you have a negative height? No, so that means the kid dropped the ball up from 125 meters. Now, they're saying, okay, cannonball. Cannonball, the only thing causing it to accelerate downward is gravity, but it had an initial horizontal speed, which I usually will call it Vx in these equations up here. Vx, your horizontal velocity, your speed, all right, it is constant. So that means if I know what my Vx is, my horizontal speed, notice right here, it's consistently moving every second 20 meters, right? From 0 to 1 second, 20. From 20 to, right, the next second, if this is 1 second, 2 seconds, 3 seconds, 4 seconds, 5 seconds. It moves 20 meters per second every second. So for this one, the x's are going to be at 0, and then 20 meters. If I can zoom out just a smidge. The next second, 2 seconds, it's at 40. What would the third second be? 60, good. Fourth, 80, and fifth, 100. Okay, now the y. All right, damn, do I have to do this again for the cannonball? All right, I did it here for the baseball. Do I still have to do it again for the cannonball? The answer is no. When we do not have air resistance, all objects are going to fall at the same rate. So whether it's a baseball and a cannonball, bowling ball and a feather, all the objects will fall at the same rate. So pretty much this table here, you're just going to recopy it. Okay, so this was 5. The next one was negative 20 at 2 seconds. At 3 seconds, we would be at 45. At 4 seconds, we'd be at 80. And at 5 seconds, we'd be here. So combining the x speeds and our x displacements and our y displacement, you get your parabolic path. You get, this is basically what the path would be. Now the faster the thing is launched, the more the curve would look like something like that if it's launched really, really fast. If it's not launched very fast at all, okay, it'll probably plop down real short. But this is what for the most part, our path would wind up looking like. Okay. So, which of the two balls would strike the ground the first? Or which one would strike the ground first? Same time. All right, good. Same time. Same. Comparing the two diagrams, the vertical freefall on the left and the two-dimensional freefall motion on the right, what effect does the horizontal motion have on the vertical motion? So here is our horizontal motion. This one was just straight vertical. But if you look, they match up identically. All right, the 20 and the 20, the 5 and the 5, 45, 45, 80 and 80, and 125, 125. So the answer would be the horizontal motion has no effect on the vertical motion. It has no effect on the vertical motion. The diagram below shows the trajectory of a horizontally launched projectile. Positions of the projectile at 1 second intervals are shown. Demonstrate your understanding of the components of the displacement vector by determining the horizontal displacement and the vertical displacement after the 5th second. So if this is 0 seconds, 1, 2, 3, 4, 5. So right here, this would be your 5th second. So what is its vertical displacement? How far down is it from where it started? 125. All right, so negative 125 because it's below where it was. And what about the x displacement? How far is this thing from where it started? Basically take the center of the cannonball and go straight up. What number do you hit? Good, 250. So if I ask you guys, what speed was the cannonball originally shot at? Shot horizontally. How fast was it moving horizontally out of the cannon? So let me ask it like this then. How far apart are they spaced, left and right? 50. So that means if every second it is moving 50 meters in the x direction, that means it was shot out of the cannon at 50 meters per second. So you would know just by the picture that you would have had a velocity in the x direction, so a horizontal velocity of 50 meters per second. That's constant. For as long as this thing's in the air, because we have no forces in the x direction, that is 100% constant. I bet. So if a ball is launched horizontally from the top of a cliff, and it has an initial velocity of 20 meters per second, and the trajectory is shown below, express your understanding by filling in the blanks. All right, so at 0 seconds, right there, you have a Vx of 20 meters per second. What is the Vx going to be, guys, then? At the next second? It will have moved, right? It's going to move an additional 20 each time, but they're not asking for displacement. Right now they're asking about the velocities. So how do we figure out the horizontal velocity? And the answer to that, if you guys look at the other pieces here I showed you, Vx, horizontal velocity, it's constant because there's no forces causing it to speed up or slow down, right? Gravity only acts in which direction? Right? The vertical part. So since there's nothing pushing it or slowing it down in the x, guess what? These are all 20. All your Vx's here are 20. All right, sick. That's great. But Mr. Lombardo, now what the hell do I do for Vy? Glad you asked. So I tried breaking it down, guys, into your horizontal set and then your vertical sets. Vertical motion. Pretty much you have your vertical displacement, your vertical velocity. They want vertical velocity. All right, so Vy, if y is right, standing for your verticals. So what does that equation equal right here, guys? GT. So if Vy is equal to GT, and what we say G is going to be for us? -10. So for 1 second, if t is 1, what's -10 times 1? G doesn't change. So what would, if you're in the air for 2 seconds, what is the velocity going to be now? -20. If it's in the air for 3 seconds, and then do we even show the math for the next one? Or do you guys see the pattern? So if I said I dropped a ball off the top of the world's tallest building and it was in the air for 8 seconds and there's no air resistance, what would its vertical velocity be as it hits the ground? If it's in the air for 8 seconds, -80, right? So basically saying the -80 is saying 80 meters per second on the way down. All right, so the biggest pieces of like the reason I wanted to show this is because visually, all right, your distance, okay, that stays constant in the x direction because every second you're going to move the same amount, right? In this case, if I'm moving 50 meters per second, well then every second, all right, yeah, I should be moved over 50 meters. If I was using this example, all right, or if it was like, every 20, they would be at 20 meters per second every second. They would be evenly spaced. The distance changes, all right, because every second you're falling, you're gaining speed, so the distance in between each fall should increase. And then your velocity is going to wind up increasing, all right, on the way down, all right, by 10 meters per second every second that it is in the air. Okay. If the ball in the diagram above strikes the ground after 4 seconds, how high was the cliff? And how far from the base of the cliff will the ball land? Okay. So at 4 seconds, what do we have? 40 meters. All right, we have a Vy of 40 meters per second and a Vx of 20. So let's say we know those things. Vy, -40. We said Vx is 20. And then what else are we given? Time. Very good. 4 seconds. So when they say how high, are you thinking x direction or y? Y. So if that's the case, you go to your y set of equations. All right, and pretty much this is speed, this is like height. All right, it says vertical displacement. Vertical displacement can be height. What is the equation for that? 1/2 gt squared. So we said g was -10. What's 1/2 of -10? And we were in the air for a total time of 4 seconds. And you only squared the time. 4 squared, 16 times -5. Right, would be -80 is your displacement. But if they want to know how high it is, get rid of the negative. So it's 80 meters. Now, if it says how far, right, how far from the base, how how far from the base. I tried putting some of that, like some of the terminology, I guess, in some of the questions, right? Horizontal displacement or distance. How far away does it land? How far from the base? What's the total distance it traveled? You're looking for delta x. And how do I use the triangle? Cover it up. Delta x is equal to Vx times time, because they're next to each other. I also have it written out here. Vx times time. And we were given Vx of 20. And what was our time again? 4 seconds. And what's 20 times 4? So we would have landed 80 meters away. Oy vey. Okay. So, this is a good question. This is still a good question. All right. If the object is still in the air for 4 seconds, is it going to change how far it fell? So if I rolled the ball off the top of my desk, and it was in the air for 4 seconds, right? And I rolled it off pretty fast, and it landed 80 meters away, just for the hell of it. Okay. If I now, instead of rolling it at 20 meters per second, if I roll it at 16 meters per second, is that going to change the fact that I rolled it off the top of my own desk? No. So it still would fall the 80 meters. But now, do you think, because I rolled it slower, so instead of rolling it off the top of my desk, right? So if I tried to just, okay. So if I rolled the first one off with a Vx of 20, and it hit right here, which is a distance of 80 meters. I'm still rolling it off my desk. Now they're basically just saying, okay, well, instead of you launching it off there at 20 meters per second, they said, okay, well, now you're only going to launch it at 60 meters per second. So do you think it's going to go 80 meters, more than 80 meters, or less? Less, right? Hopefully, guys, that makes sense. So if I push the ball off the top of my desk, and it lands 80 meters away, now I'm pushing it again off the same desk, so it's the same height off the ground. So gravity's going to have it still be in air for the same amount of time. But if I don't roll it as fast, yeah, it definitely shouldn't go as far. So it should be less than 80 meters. So all that you needed to do in this one is they're looking for, again, how far from the cliff. So they want delta x. Delta x would be equal to Vx times time. Since we're still launching it off of the same, cliff, time is still going to be 4 seconds. But our Vx, instead of it being 20, is going to be 16. So all you're doing for this one is going to be 16 times 4, and you're going to have, God bless you, 64 meters away. And does that make sense that it's not as far? Because I didn't roll it as fast. All right, let's see what in the hell I got here. So we can write this equation down. Or we'll just write V. So V will equal the square root of Vx squared plus Vy squared. Because as the object is striking the ground, it's going to have part of its speed is Vx and part of its speed as Vy. So we would have if you combine these two into a vector, the resultant would be what we're looking for, v. That's what we're looking for. So that's why you have to use this equation. Okay, this equation, I'm not going to make you guys do this all the time. It's just on this assignment, so we're just going to run through it. All right, so what do we have? A ball is launched, all right, horizontally, all right, it's projected horizontally from the top of a 92-meter high cliff. So guys, height, x or y? Y. Okay, so basically these are my y sets. What do I have? G, that's going to be -10. Time, well, that definitely didn't seem like a time. So was that a vertical velocity or like a height or displacement? That 92 meters. Height. So that's dy. And it has an initial speed of 19.8 meters per second. Now, remember, because it's being launched horizontally, it has no Vy, it has no vertical speed yet, right? Because it hasn't left like the top of the cliff or the desk or whatever we're rolling it off of, throwing it out of. So all of our speed right this second is this 19.8 meters per second. Okay. What do they want? They want horizontal displacement, which is delta x, and then they want b, the final speed. Well, guess what? I already have Vx. So I'm going to need to find Vy as well, technically. Okay. So, Mr. Lombardo, great. This is awesome. I'm not sure what to do. Okay. So what we do is once we know what we're looking for, guys, you're going to go to your little formula sheet here. Delta x. What is the equation for delta x? Vx times time. Do I have Vx? Yes. So I'm going to just say, okay, cool, I got that, bet. Do I have time? No. So there's two time equations. Time is what connects both of the problems together. You have a time in your x equations, all right, and we have time in our y equations. So notice what I have right here. Usually in these problems, you'll wind up needing to find time first, all right, and then go to the horizontal equations or vertical equations after to find the final thing. If you have both Vx and t, use the triangle, and you would use delta x over Vx. But if you're not given both of those, you're going to be given height, which is dy. So then you're going to use this equation. 2 times the height over gravity, but we can't use negative because negative in a square root doesn't work. That's why I just wrote 10. So this is what you have to do first. So we have to find time first. So we have to go on a little side quest. Okay. So to find t. Yep. Side quest. 2 dy over 10 square root. dy was 92, so you're going to do 2 times 92 divided by 10 and square root that. Okay, so 2 times 92. Do that in a calculator and then divide it by 10. Get 18.4, and then you have to square root that answer. And you're going to get 4.289, so we'll call it 0.29. seconds. Now that I have this, now I can solve for my delta x. Right, so I'm going to bring this 4.29 back. So 4.29 times 19.8. 84.94 meters. So you solved for part A. Now, if I wanted to know the full velocity which I need to hit the ground first, I have Vx. What don't I still have? Vy. We found, well, we were given dy, but we don't have the vertical velocity. So I go to my vertical set. What is the equation for Vy? Gt. Oh, snap. We already found t. So Vy is going to be Gt, which is negative 10 times 4.29, which will give me our 42.9 in the negative direction. Okay, so the only other thing in this is, again, when we go to square root something, we don't want the negatives in there. So we're going to basically just say that our Vy, instead of it being negative 42.9, we're going to say 42.9. And we got to square that. So in our calculator, 19.8 squared plus 42.9 squared. Okay, so we got to take the square root of this, whatever the hell this number is. 2232.45. God bless you. Bless you. So 47.2, we'll call it 47.25. Now that was a harder problem. We had a couple different things to do, but for the most part, guys, you're going to be given enough information and you're going to need to solve for t in some form or another. So if you're given both of these two, you can use this to find t, and then you'll probably use t to find either your vertical velocity or your height. If you're not given both of these and you're given height, you use this to find t, and then you'll be given one of these other two and use t plus whatever your other x piece is to find the missing. All right. So I know that one was a little bit of a beast, but if you have a pretty decent understanding of what's going on in that, you're going to be very, very good with this. All right, let's break down number 10, launch speed of a horizontally launched projectile that lands 26.3 meters from the base of a 19.3 meter high cliff. What variables am I given? If it lands 26.3 meters from the base, good, delta x. 26.3 meters. And then what else am I given? The height. So height is in the y direction. It's not vertical velocity. It would be your vertical displacement or height. So we're given dy. $19.3 meters. What the hell do they want? Determine the launch speed of a horizontally. So because it's launched horizontally, there is no Vy yet. They want to know what the initial speed was, so that is your Vx. Okay, here are my variables. I know what I'm looking for. So what would my next step be? If you know what you're looking for, you want to write out what that equation is. So what is our equation for Vx? Yep. So we are going to have Vx is equal to delta x over time. I already have delta x, 26.3. What don't I have? Time. So I'm looking for this guy. I have this guy. I don't have t. So obviously I can't use this equation because I don't have. No, I'm looking for Vx. Whoop. Looking for this. Have this. Don't have this. So I cannot use this t equation. And notice I put a little star here. If not given time, you're usually given height, which is dy. If that is the case, use this equation to solve for time. So side quest, find time, and then you can plug it into, all right, your equation. So to get t, we're going to go 2 dy over 10 and square root, which you're going to wind up having to do a lot, guys. So 2 times 19.3 over 10 and square root. So 2 times 19.3, 38.6 divided by 2, 3.86, and we have to square root that. And I get a time of 1.964 and change, so we'll call it 1.96 seconds. So I need that for this dude. So 26.3 divided by 1.96, and that will kick out an answer here of 13.418, so we'll call it 13.42. Try and round it to 2 decimals. And what would my unit be if it's velocity? Very good, meters per second. That's a normal type problem. 9 was multiple steps, so it was kind of a pain, like, because they asked you for several different things. But for the most part, this would be the type of kind of problem you guys are going to be looking at. Horizontally kicked ball at 15 meters per second. That would be your Vx. On top of the field house, and it lands 35 or 33.9 meters away from the base. So that's Vx. They want dy. They want to know the height. So go to my vertical set of equations. How do I find dy? 1/2 gt squared. All right, cool. I know what g is. What don't I have? T. So what do I have to do? Side quest. I know it happens in most of the problems. So, okay, I can't use this equation to find t because I'm looking for dy. So that doesn't work. So if that doesn't work, that means you pretty much have to be given Vx and delta x. So you're going to use this equation to find time. Delta x divided by Vx. So we're going to do 33.9 divided by 15.8. And this gives us 2.1455, so we'll call it 2.15. seconds. And now that you have that, we'll plop it in. What's 1/2 of g? G is -10, so what's 1/2 of -10? -5 times t squared. And if t is 2.15, you're going to square that. 2.15 squared times -5. God bless you. Now that gives me negative 23.11 meters. Now, dy is technically what? Displacement. So what is this? Is this a valid answer for when they ask you to solve for the height? How high was the house? No. So what do? Just drop the negative. Okay. So now you have this next piece, which should be a little bit easier because I already have labeled on there what your variables are and what you're looking for. Stone is thrown horizontally from the top of A. How high is that? 572 meters high. How long does it take to reach the bottom of the cliff? This one's super quick because it doesn't actually. We don't have to find anything in the x, so this one should be pretty straightforward. Okay, you have dy 572. You can, if you're given height, you can find time by doing 2 times dy over 10 in square root. 2 times 572 over 10, square root that, and it's going to come out to be about 10.9 or 10.696 or 10.7 seconds. Either one of those, super, totally cool, acceptable answer. Okay, how far does a ball land from a cliff? All right, how far does it land from the cliff? That is your delta x. If it has a horizontal speed of 26 meters per second and it's in the air for 7.7 seconds. So delta x, that equation, if I look up at the top, delta x, vx times time, all right, delta x, vx times time. I already have those two pieces of information, so all I'm going to have to do is multiply. All right, you guys can do that one, super simplistical. Let's move to one where you have to do a side quest. Steel projectile shot horizontally at 24 meters per second from the top of a 1,258 meter high tower. How far from the base of the tower does the projectile hit the ground? I wrote need time first. So they want delta x. Vx times time. I'm given Vx is 24 meters per second, and I'm given a height of 1,258 meters. So I can put under Vx, I can put 24. But I can't do anything yet because I don't have time. If you're given height, you can find time. So we got to do a little side quest. 2dy over 10, square root. And this comes out to be 15.86 seconds. Okay, because I needed t first, so once we get t, okay, we can bring it back. And then delta x comes out to be 380.64 and the unit meters. Okay, so everybody good with this one here? So you're given delta x for number 4. You're given delta x of 47. You're given a vx of 15. They want dy. So in order to solve for dy, you need time first. If you're given both of the x's, you can find time with our equation here. Delta x over vx. (47 over 15), and that gives us 13.3 seconds. And then dy is just 1/2 gt squared. What's 1/2 of -10? And then timesing that by 3.13 squared, and that comes out to give us a negative 48.98 meters. But if they want to, again, know how high the cliff is, we just got to drop the negative sign. So the final full answer would be 48.98 meters. Number 5 is very, very similar. Actually, it's pretty much an identical type of a problem. So let me see. We've done one where you need to find a delta x. We haven't done one where you needed to find a vx. All right, so then let's take a look at 7. A 25-pound frozen turkey is launched horizontally out of a helicopter that is hovering at 112.5 meters above the ground. If it travels a horizontal distance of 55 meters before it hits the ground, what speed was achieved from the helicopter? Okay, so we do need time first. If I was given dy 112.5 and delta x of 55 meters, and Vx is delta x over t. If I have delta x of 55, what don't I have? Time. Side quest. Correct. So if you don't have time but you're given height, you can do the 2 dy over 10 square root. So you're going to do 2 times 112.5 over 10 and square root. And this whole thing would come out to be 4.74 seconds. And now take that and throw it down here. And so your Vx will equal 11.60 meters per second. All right, number 8 is super simple. It's just you're given time. They want to know Vy, speed at which it hits the ground vertically if it was just dropped from that spot. All right, so if they just want Vy, you're just going to do Vy is equal to G times T. Yes, I can. Is everybody good with 7? Okay, so then you have 5, 6, and 8 for homework, which you guys could probably finish right now. And this was, you said you needed 4?